Welcome back, Focus Learners. Today, we're throwing the standard agenda out the window because we are diving straight into the fascinating and honestly sometimes confusing illusion of AI magic. We hear terms like ChatGPT, transformers, and LLMs thrown around literally everywhere. But what's actually happening inside these machines? Are they actually thinking? Or is it all just an incredibly complex parlor trick? Well, let's demystify the whole shebang together in today's explainer.
Okay, let's dive into this. Because it's the ultimate modern paradox. On one hand, artificial intelligence can pass the bar exam in the 90th percentile. It can write incredibly complex computer code. But on the other hand, because of the way it learns, it might not actually know what a physical cat is. To understand how both of these things can be true at the exact same time, we really need to look at how these systems are built from the ground up.
Section 1, the next word game. So, if you're a student, a working professional, or honestly just someone trying to navigate the digital world today, we have to strip away the sci-fi movie tropes. We need to look at the core function driving this entire revolution. At its heart, a large language model, or LLM, is not a brain. Actually, scratch that. It's more like a massive statistical engine. It's been trained on an absolute ocean of data, books, articles, websites, with one incredibly simple goal: find the most probable continuation of a sequence. It is constantly, relentlessly asking itself one question. Based on what I just saw, what is the mathematically most likely next piece of text?
But here's the thing, it doesn't quite see words the way you and I do. Think of human language as a giant bucket of Legos. To process our complex thoughts, the AI breaks language down into little manageable chunks called tokens. A token might be a whole word, maybe just a part of a word, or even a single character. By breaking the vast universe of human language into these calculable, bite-sized Lego pieces, the model can rapidly rearrange them to build infinite linguistic structures.
And this brilliantly illustrates something you probably use every day. Think about the autocomplete feature on your phone. The one that guesses the next word in your text message. Well, an LLM is essentially that exact same mechanism, just scaled up to a massive, almost incomprehensible degree. It's basically autocomplete on steroids, capable of completing thousands of tokens in a row to generate an entire essay or, a haiku about your dog.
So here's the quick TLDR for our first point. LLMs are not thinking in the traditional human sense. They're playing the next word game. They break text into little Lego-like tokens, and they act as an impossibly powerful autocomplete, predicting the next piece of the puzzle step by step.
Section 2, inside the AI brain. Now that we know what game the AI is playing, how exactly does it make these rapid-fire predictions with such crazy accuracy? Well, the secret sauce is an architecture called the transformer, and it works in a simple three-step recipe. First, it tokenizes and embeds, meaning it translates our words into a secret code of numbers. Second, it pays attention. And third, it predicts the probabilities for the next token. But it's really that second step, the attention mechanism, that completely changed the world. Now, what's really interesting about this is how it grasps context. Imagine you're reading a really long book and you're using a highlighter. When you read a specific sentence, your attention isn't just focused on the words immediately next to each other, right? You highlight and connect related words from pages or paragraphs ago to understand the current context. The attention mechanism works exactly like that. The transformer architecture allows the AI to dynamically weigh the importance of all the words in your prompt, no matter how far apart they are. It essentially masters long-range context. But remember, the AI doesn't have a giant hard drive containing a literal copy of the whole internet to look things up. AI researcher Andrei Karpathy uses this great metaphor of a 140 gigabyte zip file. To put that into perspective, an LLM is basically a highly compressed, slightly blurry memory of the internet woven directly into its digital brain. When you ask it a question, it's not searching a database. Instead, it's hallucinating or dreaming up text directly from that compressed statistical distribution. To wrap up Section 2, transformers are the core engine. Their attention mechanism acts like a highlighter, connecting distant related concepts. And the models themselves function as massive compressed files of statistical knowledge. Section 3, the intelligent parrot debate. With all those mechanics in mind, what is actually happening when this compressed knowledge generates an answer? Well, we have a fierce academic divide going on right now. On one side, we have the stochastic parrot hypothesis. This argues that LLMs are just mindless statistical mimics. They learn the shape and form of language, but they have zero grounding in actual meaning. But on the other side, we have the emergent intelligence hypothesis. This side argues that by predicting the next word so accurately across billions of data points, the model is forced to actually internalize the underlying laws of the world, building a genuine conceptual world model. So the crucial point is figuring out if this is pure mimicry or if there's the possibility of genuine reasoning. The parrot side brilliantly illustrates their point using something called the octopus thought experiment. Imagine a deep-sea octopus that manages to intercept a communication cable between two people stranded on a desert island. The octopus learns the statistical patterns of their conversation and mimics them perfectly, but when it talks about a coconut, it doesn't actually know what a coconut is. It's never tasted one, it's never felt its weight, or even seen it. Philosophers call this the symbol grounding problem. It's the idea that just because you can produce fluent text doesn't mean you actually possess true understanding. However, AI pioneers like Geoffrey Hinton offer a really compelling counter-argument. He suggests that to predict the next word with the staggering, mind-bending accuracy that these models do, you simply can't just rely on shallow statistics. You have to understand the sentence. Some researchers point to the complex logic these models display, like solving completely novel math proofs, as evidence of reasoning abilities that go far beyond just rote memorization. So, could they be doing something deeply computational that we just don't fully understand yet? It's absolutely a possibility. Section 4. Metaphors for working together. Regardless of where you fall in the intelligence debate, the fact is, these tools are here and they're incredibly powerful. So how should we actually use them? UX expert Jakob Nielsen observed that back in 2023, we kind of treated AI like an eager but clumsy intern. And it was a great metaphor at the time. You gave it grunt work, but you had to supervise it heavily because, well, it made mistakes. But treating modern AI just as an intern severely limits our potential. We really need some new, versatile collaborator metaphors. The first new metaphor is thinking of the AI as a coworker. When you're stuck on a project, don't just hand off a task and walk away. Treat the AI like a coworker. Alternate taking the lead. The AI provides relentless, out-of-the-box creative ideation, ideas you might literally never think of. And then you step in to provide the necessary human judgment to filter out what simply won't work in the real world. It's a real back-and-forth collaboration. Let's move on and see how this builds when we consider AI as a teacher. When you're facing a topic you know absolutely nothing about, you can use the AI to guide you through acquiring completely new skills. It can break down really complex knowledge paths, simplify crazy concepts, and provide relatable examples until you fully grasp a brand new subject. And finally, the AI as a coach. Now, you might actually be way better at your job than the AI is. But think about it. A gymnastics coach doesn't have to be able to do a perfect backflip to correct an Olympic athlete's form, right? You can feed your work to the AI and ask it to critique you, have it spot your blind spots, and force you to justify your decisions. This takes the skills you already possess to totally new heights. You're still the undeniable expert in the room, but you're using the tool to sharpen your edge. So it's time to ditch that intern mindset. Look at your next task and ask yourself, do I need a coworker, a teacher, or a coach today? Depending on your problem, use it as a coworker to collaborate, a teacher to learn entirely new things, or a coach to get critical feedback on the skills you already have. Section 5. The new operating system. So what does this all mean for the future of our digital lives? As AI researcher Andrei Karpathy notes, thinking of an LLM as just a text-generating chatbot is looking at it way too narrowly. It is rapidly becoming the central kernel process of a brand new operating system. It sits right in the center, coordinating tools, browsing the internet, accessing your memory files, and problem-solving across audio, visual, and text formats. It's truly becoming the new interface between us humans and the digital world. But whether you see this technology as a brilliant new coworker or just an incredibly convincing stochastic parrot, there's one absolutely undeniable fact. The fuel powering this entire revolution is big data. It's the vast oceans of human knowledge, creativity, and communication patterns scraped from the internet, which leaves us with a pretty profound question about human responsibility and the data we create. Ultimately, who taught the parrot how to speak? Think about that as you interact with these tools. Keep learning, keep experimenting, and we'll catch you in the next explainer.